For nearly 50 years, Voyager 1, NASA's most distant and legendary space probe, has been on an epic journey across the cosmos. Launched decades ago, it continues to move deeper into uncharted space, all while sending back valuable data to Earth. But recently, this silent traveler has started transmitting signals that have left even the most seasoned scientists speechless. Data from Voyager 1 has always been groundbreaking, but now it's become mysterious, even alarming. Could these strange signals be the result of a technical issue, or is there something far more bizarre going on? Maybe something beyond human comprehension? Stay with us as we dive into the chilling reality behind these signals, and what they could mean for the future of space exploration. Human curiosity has always reached beyond the stars. Since ancient times, we've looked up at the night sky and wondered what lies out there. This relentless desire to explore pushed scientists to launch ambitious missions like Explorer 1 and Explorer 2, historic undertakings that paved the way for modern space exploration. The journey truly began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977. Just 2 weeks later, on September 5, Explorer 1 was sent up into space. Though they were twin probes, each weighing 720 kilograms, roughly the size of a small car, their paths diverged in speed and direction, creating two very unique missions through our solar system. These probes were launched during a rare planetary alignment that only happens once every 176 years. This clever timing allowed the probes to use gravitational assists, like cosmic slingshots, to gain speed and leap from one planet to another. Just a few months into their journey, a critical milestone occurred on December 15, 1977. Explorer 1 overtook its twin due to differences in their courses. From that point on, Explorer 1 became the more prominent of the two, continuously sending back incredible data that would expand our knowledge of the universe in ways we never imagined. Before its most recent and disturbing discoveries, Explorer 1 had already made history. Let's rewind to the year 1978, when Explorer 1 embarked on its Jovian imaging mission. At that time, the spacecraft was about 265 million kilometers away from Earth. Even from this immense distance, it managed to capture and send back thousands of images, stunning photos of Jupiter and its surroundings. Then, in January 1979, it began a remarkable 100-hour time-lapse project, capturing 10 complete rotations of Jupiter in a mesmerizing visual sequence. This effort gave us 3,750 images that showed Jupiter's swirling storms and powerful atmospheric dynamics like never before. What Explorer 1 uncovered next shocked the entire scientific community. As it cruised through Jupiter's moon system, it discovered something previously unknown: a thin ring encircling the planet as well as two entirely new moons. These findings were monumental. They not only revealed new features about Jupiter's ecosystem but also changed our assumptions about what gas giants were really like. But the mission didn't stop there. To safely reach the next target, Saturn, the spacecraft had to avoid colliding with Titan, Saturn's largest moon. This required NASA to perform delicate maneuvering, carefully guiding Explorer 1 through the dark void. Upon arriving at Saturn, the probe continued to impress. It detected and recorded 4 additional moons: Mimas, Enceladus, Tethys, Dione, and Rhea. Each of these moons held its own mysteries, and their discovery once again confirmed that our solar system was far more diverse and dynamic than previously believed. After finishing its Saturn mission, NASA made a bold decision: to send both Explorer probes beyond the edges of our planetary system and into interstellar space. Now moving at an unimaginable speed of 325 million kilometers per year, Explorer 1's journey was only just beginning. A new era began in January 1990 with the launch of the Explorer interstellar mission. It was during this phase that Explorer 1 delivered one of the most iconic space images of all time, the family portrait of our solar system. This breathtaking series of photographs showed the Sun and most of the planets from a vantage point 6 billion kilometers away. The idea came from a passionate astronomer named Dr. Vasily Sands, a member of the mission's imaging team. He fought hard for this final picture as a goodbye gift from humanity to humanity. Despite initial resistance, his dedication paid off, and on February 14, 1990, Explorer 1 captured 60 unforgettable images, wrapping up its planetary imaging mission in dramatic fashion. But the story doesn't end there. While Explorer 1 was soaring deeper into space, its twin Explorer 2 was also accomplishing great things. During its flyby of Neptune, Voyager 2 detected wind speeds exceeding 13,100 meters per second, the fastest wind ever recorded in our solar system. As it skimmed just 280 miles above Neptune's deep blue methane-rich atmosphere, it sent back critical data that expanded our understanding of this icy giant. It also gave us a closer look at Neptune's moon Triton, revealing it to be one of the coldest places in the solar system, with surface temperatures plummeting to -391 degrees Fahrenheit. Even more amazing were Triton's nitrogen ice volcanoes that spewed frozen particles nearly 5 miles high into its hazy skies. These revelations helped us understand the wild diversity of worlds that exist even within our own planetary neighborhood. But that was just a glimpse of what the Explorer probes were capable of. And you'll want to stick around because Voyager 1, which we're calling Explorer 1 here, has recently made a chilling discovery that could change everything we think we know about deep space. Before we dive into those latest transmissions, let's appreciate just how much these twin probes have achieved over the last 45 years. Back in the 1980s, when these missions were still young, scientists were already shocked by what they saw. Initial scans of Jupiter's and Saturn's moons challenged everything. They thought these moons would be inactive, lifeless rocks, similar to Earth's moon. But instead they found active geological activity. One of the biggest surprises came from Explorer 2, which flew by Uranus in 1986, becoming the first and only spacecraft to do so. Then, in 1989, it became the only probe to ever visit Neptune. No spacecraft since then has made it to these distant planets, making its findings all the more important and unique. Over the years, NASA has worked hard to keep these probes running. To conserve their limited energy, unnecessary instruments and heaters have been shut down. These decisions have extended their missions much longer than anyone thought possible. Currently, both probes are expected to operate until around 2030. For the teams who've worked on them since the beginning, watching these missions come to an end will be bittersweet, a mix of pride and nostalgia. But there's no denying the legacy these crafts have created. They've given us a mountain of data, reshaped countless theories, and sparked the imagination of space lovers around the globe. Voyager 1 and 2 weren't just average spacecraft. They were built for longevity and precision. They rotated more slowly than the hour hand on a clock, which helped reduce motion blur in their cameras, crucial for capturing clean images while moving at high speeds through space. Even before reaching the gas giants, their cameras were sending back fascinating views. One of the first awe-inspiring images showed Jupiter's swirling atmosphere and famous Great Red Spot, long before a close flyby. But what really blew minds was the discovery of volcanic activity on Jupiter's moon Io. Io, which is slightly larger than Earth's moon, turned out to be the most volcanically active body in the solar system. Voyager detected strange signals from it and later confirmed them with images showing massive volcanic eruptions. One volcano on Io exploded with a force 10 times more powerful than Mount St. Helens, covering an area nearly the size of France in volcanic debris. These discoveries didn't just wow scientists, they completely redefined our understanding of moons and geological activity beyond Earth. Eventually, to save energy for the long trip into interstellar space, Voyager's cameras were turned off. Interestingly, the spacecraft never took close-up photos of Mercury or Mars for various mission-related reasons. Aside from Explorer 1 and Explorer 2, NASA also operated other space missions like Voyager 10, Voyager 11, and New Horizons, but it was Voyager 1 that truly made history when it flew past Voyager 10 on February 17, 1998, officially becoming the most distant man-made object in space. Explorer 1 continued its lonely journey into the great unknown. And on August 25, 2012, it finally crossed into interstellar space, the region between stars. No other spacecraft was nearby to witness this milestone. NASA didn't even announce the achievement until a year later in 2013. But behind the scenes, a lot of brilliant planning went into making this possible. One strategy was particularly genius: the use of gravity assists. These maneuvers used the gravity of planets to boost speed without using extra fuel. Without these slingshot moves, reaching the outer planets would have taken far longer, or maybe never happened at all. The spacecraft required more than just their own propulsion systems. They needed an additional boost, and gravity assists provided exactly that. Picture two fearless rockets, Voyager 1 and Voyager 2, embarking on their grand tour through the local planetary group. Instead of relying solely on their motors, these spacecraft engaged in a celestial dance with some of our solar system's heaviest planets. These planetary giants, Jupiter, Saturn, Uranus, and Neptune, formed gravitational groups that performed a remarkable dance, leveraging their immense gravitational pulls to slingshot the spacecraft, propelling them forward. This method allowed them to conserve valuable fuel while gaining the necessary speed to visit various destinations in our solar system. The fundamental concept behind gravity assists, also known as gravitational slingshots, is simple yet ingenious. When a spacecraft passes near a planet, some of the planet's energy is transferred to the spacecraft, accelerating it to a higher velocity. Let's consider the example of Explorer 1, which approached Jupiter, a massive gas giant with a powerful gravitational force. The spacecraft swung by Jupiter at just the right angle and speed, and Jupiter's gravity tugged at it, boosting its velocity significantly and sending it on its way. Executing a gravity assist maneuver requires extreme precision. If Explorer 1 had approached Jupiter at the wrong angle or speed, the slingshot could have caused a disastrous deviation from its intended path, derailing the mission. The level of accuracy required for these maneuvers is staggering, but the brilliant minds behind these missions successfully performed multiple gravity assists, propelling the spacecraft through the solar system and beyond. For example, Explorer 2 utilized gravity assists from both Jupiter and Saturn to reach the distant planets Uranus and Neptune. These celestial slingshots were vital in making the grand tour of the solar system possible. The success of the Explorer missions was not solely reliant on gravity assists, though. Another critical element ensured their success: the Deep Space Network, DSN. Often referred to as the interstellar phone line that kept the spacecraft connected to Earth, the DSN was an indispensable part of the mission. While the spacecraft were venturing far beyond our planet, the DSN made sure they were never truly alone. The network consisted of a system of massive radio antennas positioned at various locations around the world, including California, Spain, and Australia. These gargantuan dishes, ranging from 26 to an impressive 70 meters in diameter, acted as amplifiers, enabling communication with spacecraft traveling through the vastness of space. The spacecraft, equipped with cameras, sensors, and instruments, acted as our eyes and ears in space, relaying back invaluable data. The DSN received these signals, which were faint and weak by the time they reached Earth, and amplified them so scientists could analyze the data. But the DSN wasn't just a one-way receiver. It also sent commands to the spacecraft, adjusting their trajectories, redirecting them, or tweaking their instruments to ensure the missions proceeded as planned. The DSN functioned as a two-way communication system, allowing scientists on Earth to stay in constant contact with the farthest human-made objects in the universe. One of the most remarkable aspects of the DSN is its continuous operation. It works tirelessly 24/7, listening for the faintest signals from spacecraft billions of miles away. It's like an unblinking eye on the universe, ensuring that we maintain a connection to our space probes, no matter how far they travel. Without the DSN, the Explorer missions would have been impossible. It bridged the vast gap between Earth and the distant reaches of the solar system and interstellar space. But did Voyager 1 experience a breakdown during its remarkable 45-year journey? Or could extraterrestrial beings have been involved? While Voyager 1 has remained operational and is continuing its mission successfully, recent reports have raised eyebrows. Experts have noted some strange anomalies in its performance, particularly in the signals it's sending back to Earth. These signals suggest that Voyager may first be uncertain about its exact location, creating a mystery that has captured the attention of scientists and space enthusiasts alike. What makes this situation even more intriguing is that the initial data from Voyager 1 was incomprehensible, leading NASA scientists to investigate further. Upon examination, they discovered that the culprit behind the distorted data was the spacecraft's Attitude Articulation and Control System, AACS. This system, responsible for adjusting and reporting the spacecraft's position in space, had malfunctioned. It had started sending telemetry data through a faulty embedded computer that had been dormant for years. This anomaly caused the spacecraft to send garbled data back to Earth, confusing the team. Fortunately, NASA engineers were able to fix the issue by instructing Voyager 1 to switch to the correct computer, which resumed sending clean and uncorrupted data. Despite this fix, the underlying question remains: why did the spacecraft switch to the malfunctioning computer in the first place? NASA scientists have put forward the hypothesis that a faulty command from another onboard computer could have triggered this strange behavior. However, they have not yet been able to pinpoint the exact cause of the anomaly. To get to the bottom of this mystery, Susan Dodd, the project manager for the interstellar mission, announced plans to conduct a comprehensive memory readout of the spacecraft and thoroughly analyze its operations. The mysterious signal issues aside, the spacecraft itself appears to be functioning properly. No fault protection systems have been triggered, and Voyager 1 has not been forced into safe mode. Its signal, though faint, remains strong. It seems that the spacecraft is still able to send back valuable data. However, scientists are not ruling out the possibility that the harsh environment of space could be contributing to these anomalies. Cosmic radiation and extreme temperature fluctuations could be affecting the spacecraft's components, causing electrical disturbances, data signal distortions, or even memory errors. Cosmic radiation, which consists of high-energy particles from distant stars and galaxies, can penetrate spacecraft structures and cause disruptions in electronic systems. These particles, though tiny, can have significant effects over time. Additionally, the temperatures in space can be extremely volatile, swinging between bone-chilling lows and scorching highs. These fluctuations place enormous stress on spacecraft components, despite rigorous testing and engineering to withstand such conditions. Even the most carefully designed spacecraft are not immune to the harsh realities of space. Over the years, Voyager 1 has encountered these challenges which may be taking their toll. One other theory that has sparked intrigue, though it is purely speculative, involves the idea of extraterrestrial interference. Could the unusual behavior of Voyager 1 be due to the actions of intelligent beings beyond our solar system? While this idea may sound more like science fiction than science fact, it's not entirely outside the realm of possibility. The vastness of space and the number of exoplanets it contains leave room for speculation about civilizations far more advanced than ours. However, scientists are cautious not to jump to conclusions about alien involvement, and they are carefully analyzing every aspect of Voyager 1's behavior before considering such possibilities. Whether the anomalies in Voyager 1's behavior are due to a technical glitch, cosmic radiation, or something even more mysterious, one thing is clear: the quest to understand the cosmos is far from over. The mysteries of space continue to captivate and inspire us, driving our relentless pursuit of knowledge and exploration. As we venture further into the unknown, the findings of missions like Voyager 1 will help shape our understanding of the universe and our place within it.